All right, I'm going to kick off. So I work for a company called Sensis in Melbourne. They run what is Australia's Yellow Pages and White Pages businesses. I've been involved in digital since about 2000 now. Originally with some media companies like the BBC and Sky, Channel 4 doing their content management strategies. And then I got into e-commerce, and that's really where I started to cut my teeth on search and what search can do from a consumer perspective. So I've been in Australia for about 4 years now, and at Sensis I look after what we call the content and search capability teams. So that's really the groups who look after the underlying platforms that either drive search or drive how we acquire content, how we manage it, and how we publish it across all of our different properties. So today I'm really going to talk about a project that we're in the middle of running at the moment. We're re-platforming from Fast ASP across to Solr, and we're using a project to open up all of our data as an API as really a test bed for a new search technology. So this is what I'm going to cover today. A little bit of background on the project, what it's about, what were some of our success criteria, what we're trying to get out of it. Then I'm going to talk a little bit about how we chose our platform. There were a number of platforms out there that we could have selected, so I'm going to talk a little bit about what were some of the decisions we made. And part of that is really the drivers for what we're doing with search, both from a capability management perspective. At Sensis, we're really thinking about search as a platform. It's not a bit of software that you install once and then just let it run and run and run. We actually want to manage it. So that gives us a number of requirements that, for example, a brochureware site wouldn't have. And then it's about relevance. What is relevance? How does relevance change? And what are we trying to build that supports what I'm going to talk about as contextually relevant information? I'm going to speak a little bit about the architecture and some of the key components we've developed. I'm not the technical person in this presentation. I'm sort of the business owner for the platform, so I'll go into a little bit of detail, but if you've got any questions, I can shoot those back to my developers who are just getting up now, so that's good. A little bit about quality management. It was mentioned in the last talk about testing search. So not just functionally, does your code work? Does it have bugs in it? But more importantly, how good is it at giving relevant results back to your consumers? How can you test that? What's the frameworks for testing? And how can you then build that into your development cycle so it's something you do on and on and on in a continuous way? I'll talk a little bit about some of the hurdles we try to overcome and then what's coming next. What's in the future for us? So first, Sensis. You won't know what the company is. Basically, it's an organization that helps consumers find organizations, buy from them, or advertisers sell to consumers. It started out as print directories, Yellow Pages, White Pages. We now have mobile sites, we have websites, we have map-based sites, we have a voice service. Overall, we're in the top 2 sites within Australia online. We get around 9 million visits per month to our White Pages sites and around 6 million visits per month to our Yellow Pages sites. But then we also distribute our data. So over the last couple of years, we've started to distribute our content to places like Bing Maps, to Google Maps. So we're distributing about 1.8 million business records to support that local search environment. So the project. Some business objectives, some technology objectives. From a business perspective, we wanted to drive the presence of our advertisers in the local search marketplace. We know that not everybody is going to come to our sites. Not everybody is going to come to yellowpages.com.au or whitepages.com.au. So to provide benefit to our advertisers, we need to put that information, their adverts, where the eyeballs are. So that's really about opening up all of our data to what is the entire local search marketplace. So driving that presence. We also wanted to reduce the effort for these third parties. As I said, we already have deals with people like Bing and Google Maps, but they're bespoke deals. They take time to set up. We wanted to really lower the effort so that a developer could come along, sign up, get an API key, 5 minutes later, they're actually building an app on top of our data. And it's free to use. Any developer can come along, sign up, and use our data. Actually, all we're interested in is reportable events. So if somebody clicks on an email address, if somebody sends an SMS, if somebody clicks through to further information, that's really what we care about. So all we ask for is that people provide that information back to us, and they can use our API for whatever purpose they want, even if they're creating a competitor. So this is it, the Sensis Business Search API. We went live in beta around March this year. Closed beta to start with, and about 2 weeks ago we opened it up and opened up an open beta, and we're looking at a full release in July. Developers come along, they sign up, they get an API key, it's RESTful, it uses JSON output, it's built on Java and Play, there's lots of documentation there. We even, to be politically correct, borrowed some functionality from the Guardian site, and we built an API Explorer, so you don't even have to use an app. You put in your API key, type in a search query, and you get the results out. So we really like that. I'm reusing it. There are so many search engines out there that you can buy, purchase, download. Which ones do you choose? There were some criteria for us. The first is, my team is not marketeers. They're not business people. They didn't want to get a website, get a search engine, install it, and just let it run. They understand how search works. They understand how algorithms work. They look at zero results. They use path analysis to understand whether a consumer actually gets the right results for a particular query. We wanted a platform that supported them, that gave them the levers to actually be able to tweak search and tune it, not think about it as being a black box. Secondly, I don't know if you know, but from a local search perspective, the content is very shallow. It's not like we're indexing huge articles. You might be talking about 500 words across a number of different content fields for a particular business listing. So that brings up its own idiosyncrasies and issues. So putting something like Google Appliance on there isn't really going to help you out. So what we needed was a search engine that would support structured data and support faceted exploitation of that data. As I mentioned, we wanted something that was deterministic. There are a lot of search engines out there that you put in a keyword, it gives you a set of results, and you haven't got a clue why. It's literally a black box. It's not there to be managed. You can't interrogate it. One of the great things about Solr is it exposes quality scores and actually how the quality score was derived. So you can delve down into it and find out why a particular result appeared where it did. And I'll talk a little bit later on about a platform we've built that exposes that information and really supports us in improving search. Non-proprietary code bases or non-proprietary languages. Again, there's a lot of search engines out there that you can buy that you've got to learn another language before you can even use it. You've got to go on training courses. Again, something we didn't want. Australia is a small place. Well, it's a big place, but it's only got a few people. And they're all around the edges, funnily enough. We haven't got a huge community of developers. So if you go out and buy a proprietary bit of software, you've got to teach those people. They leave 6 months later. You've got to bring more people in and train them. So we wanted something that was easily used, something that was easily picked up, and also had a wide community, so we didn't have to be supported by somebody in America who was only around, 6 hours of the day, or somebody in Singapore who was only around 8 hours of the day. So we looked at a number of platforms, whether they be local search providers, whether they be rich content providers, whether they be retail sites. So, we looked at Endeca, we looked at Exelead, we looked at Solr. And really, when you looked at all of those criteria, Solr jumped out at us. We did a couple of proof of concepts, one with Exelead, one with Solr, and the key thing was our developers just loved it. To be honest, I would have been lynched if I'd picked anything else. They would have just left. And it's funny, but you don't put this on your big matrix of selection criteria when you're choosing a platform, but developers being annoyed with you should be on there, because it's really important, and you get so much buy-in from going with a platform that they enjoy working with, and not something that they feel is working against them every single time. This is one of the pillars that supported us in the selection process. It's called the Search Capability Maturity Model. It's based on Carnegie Mellon's Capability Maturity Model that really talks about how mature are you as an organization in managing a capability. Now, that capability could be anything. It could be how you manage projects. It could be how you do service-oriented architecture. It could be how you build houses. It doesn't matter what it is, but it's managing something as a capability. As you move up the pyramid, or in this case, the mountain, you get more mature. And as an organization, you need to work out where you want to be within that maturity model. What's the benefits you're going to get out of it? And then you can plot where you are and where you want to be. So it actually helps you plan out how you're going to improve. And this is one of the key characteristics we wanted from the platform that we selected, was to support us moving up this maturity model. So if you think about people who just install software, let it run, never touch it again, that's level 1. That's unmanaged. There's no resources, there's no reporting, it's out-of-the-box features. Sometimes you might run a project. It might be ad hoc. Maybe 2 years after you've installed your platform, you think, maybe I should go back and look at it again. Where did it not work? I've got some money, I'm going to fix some problems. That's ad hoc. That's ad hoc processes, it's part-time teams. It's about individual-led innovation. It's not an organization saying we want to be good at this. It's an individual going, I'm sick of this thing not working, I want to fix it. The next level is monitored. This is where Sensis is at the moment. We have a team. We have processes. We have reporting. So every month we put out a dashboard that says how good search is, and we quantify it. We have a quality score that we can track to see whether it's going up or down, and it's made up of some qualitative metrics and some quantitative metrics, user satisfaction surveys. All of these things come together so that I can put something in front of the CEO that goes, we're getting better, or we're getting worse and you need to give me some more money to fix it. It works sometimes. What we're aiming for is that next level, the managed. This is where you've got not just the people, but the platform that allows you to fix the problems. So being monitored knows you know where your problems are. Being managed is actually, I can fix it and do something about it. And that doesn't mean writing a whole heap of code base around something. It's actually providing those management levers. And where we're aiming for, well, that's optimized. That's where Google is. It's where the big search players are. It's about A/B testing. It's about machine learning. Jesus, I wish we could do machine learning. It's about external collaboration. And what we found is it's very difficult to jump levels. We were at sort of the level 2 ad hoc stage, and we tried to get some external collaborators working with us from some universities around Melbourne, and it just didn't work. It was too much of a jump to where we were, to where we wanted to be, to actually gain the benefit from that. So what we found is, even though you want to make big jumps, you've got to move through these levels one by one. And that's really one of the key pillars of this project, was to understand that and support us. The next pillar is context. Now, I'm speaking to the converted here, but context is key. Search hasn't changed for about 10 years. You have a text box, you put in some keywords, you press the search button, and here's some results. So you've got a 12-year-old schoolboy in the playground on his mobile phone at lunchtime doing a keyword-based search, gets exactly the same results as a 60-year-old retiree, 10 o'clock at night on the weekend at home on their PC. Now, to me, those two people are very different, and I would expect the results that we give them back to be very different. But the way that search works at the moment, they get exactly the same results. So for us, context is key to relevance. We need to take all of the contextual information we have about a person, their environment, their platform, and use that to give more relevant results back. So here's some of the contexts. Location. You'll find a lot of local search platforms use location in a very specific way. They use it as a filter. I search for a pizza joint in San Francisco. I might look in the San Francisco area. If I don't find anything, I might go out to surrounding suburbs. But that's it. Everything outside of that area is just not even brought into the relevancy equation. What we wanted to do was use location as part of the relevancy model, because location changes. The impact of location on how relevant a result is changes depending on what you're searching. So let me give you an example. It's 11:30 at night, I've just come from the pub, I'm a little bit worse for wear, and I need a pizza. I'm starving. That pizza place being 100 meters away from me or a mile away from me makes it relevant or not. But then turn that around, it's Sunday morning, my hangover's gone, I'm building a deck outside, I need some timber, I need to go to the local DIY store. I'm going to drive there in my car. Whether that place is 15 miles away or 20 miles away actually makes very little difference to me as long as they've got the timber for me. So in that instance, location actually shouldn't be weighted very highly. It's quite irrelevant to me as long as it's a roundabout. So location is an important factor in whether results are relevant or not, changes depending on what you're searching. So what we've done is we've built that into our relevancy model. Some other intents, or other contexts. Chronology, time of the day of the month, month of the year. Language changes. The meaning of language changes. I can search for skis in winter, and I mean alpine skis. Or I can search for skis in the summer, and I probably mean water skis. So again, just depending, same keyword, different time of the year, completely different results. Then you start to bring in things like your social graph. What do we know about people like you? What do we know about your friends? What do we know about you as an individual in your past history? And then also the device you're on. That can tell us a little bit more about your intent. How close to you, in our context, to the buying process? Are you on your PC at home at night? Therefore, you're probably further away from the buying process. Therefore, distance isn't a factor. If you're on your mobile phone, it's 12 o'clock, and I'm looking for an iPad too, location's probably very relevant to you. So again, context changes depending on the device. And then we get to intent. Again, depending on what your intent is, some things are more relevant than others. And we really use this when we start to index some of the fields that we store information in. Is your search navigational? Do you know who you're looking for and you just need to get there? So is it a name-based search? Is your search informational? So are you looking for a type of business? Are you looking for a specific product? Are you doing a geospatial search? You just want to know anything about San Francisco? Again, all of these different intents give context to what is either relevant to you or not relevant to you. And what we wanted to do was build a platform that supported these different contexts. I'll talk a little bit about how we did that. This is the techie bit, so I apologize if you really wanted technology in this presentation. A little bit about some of the key bits of architecture we've got. So, first of all, data staging. We use Mongo as a staging environment for all of our data. We have a number of different data sources for business listings information. We also have historical data. So what we do is we enhance our documents on ingestion. As I said, because we have quite shallow documents, we need to enhance it with historical information so we're better at matching a consumer's query with an actual business result. We do some deduplication. We've got some block lists in there. We do a bit of geocoding as well on ingestion. So we amalgamate all that together into Mongo. We use Mongo because it's really fast for ingesting information. We could have used Couch, but we went with Mongo. And then we ingest that into Solr. So we've got a single index, but we use multiple Dismax query handlers. So we have a different query handler for a different type of intent. At the moment, we only have name and type. In the future, we'll expand these out. But each of these different query handlers, based on a different intent, puts more weighting or less weighting on a particular content field. And that's really what gives us our contextual relevance. And I'll talk a little bit about how we can tune that in real time in a second. Then we've got our API. As I mentioned, all of this is built in Java and Play. It does some location disambiguation. It does reporting events. So as I mentioned, we don't charge for usage of our API. We just ask you to give all of those events back. So that those get sucked in at the API level and sent off to our reporting database. We also do some spelling corrections here using Jarrow Winkler. And then at the end, we have Mashery. We use it as a proxy server. It does throttling, authentication, usage tracking. It's also where the developer center sits. You'll see we've got two services. One service is our search service. The second is the reporting service. We've built it this way, because of some of the constraints around Mashery and throttling levels for different endpoints. And secondly, so that as a reporting service, we can use this in the future for multiple additional sites, properties, applications, whatever we want to do. The next thing we're going to add is another service all about reference data. So that's some of the intelligence that we use to derive a relevant result. We want to expose that to our publishers so they can understand why certain results come where they do. So all of this really is taken us on this journey. And the old platform that we have constrained us. It didn't really let us stand up. What we're building now is this new platform, moving from that black box solution to something that's actually manageable. Something that can deliver search improvements without major code changes. So as I mentioned, we want to manage search, we want to tweak search, we want to improve search without having to do major builds and deploys. At the moment, we're doing 2 weekly deploys. I want to get to a point where we're doing daily deploys, getting fixes out there. And as part of that is how do you bring testing back into the deployment cycle. Along this evolution, we also wanted to understand how results were calculated and create a scientific framework about whether search works or not. Search can be very esoteric. It's either, to a user, it works or it doesn't. It's a bit fluffy. It's very hard to go to your CEO and go, search is a bit fluffy, but give me a couple of million to fix it. You've got to really explain why it works or why it doesn't. And also to show that you're making improvements, even if it's, a couple of % a month. So what we've done is created a framework that allows us to more qualitatively define key metrics that we can track. And then bring that into this development cycle so that we continuously tune, test, deploy, tune, test, deploy, tune, test, deploy, just like any agile framework. And really, this is one of those great benefits of Solr, is it allows you to do that so easily. We looked at a number of platforms that really hid the inner guts of the platform. Now, I can only assume it's because they're commercial products and they don't want you to see how they do things, a bit like making sausages. But really with Solr, it just opens everything up, and you can understand, something stupid happens, you can get into the guts and find out why that thing happened. And we found that just enlightening. So this scientific approach to understanding quality. We do path analysis, so we look at individual user paths through the search. What did somebody search on? What did they end up? Was it a successful search or not? From that, we can define problem spaces. So that's situations where a user didn't find what they were looking for. Then we look at what was the root cause of that. What broke? Was it spelling? Was it location was weighted too highly? Was it the fact that we didn't have synonyms? Were we looking at the wrong content field? All of these different problem spaces. And then we create goal sets around these problem spaces. So a defined set of search queries with an exact set of results, so we know what that perfect set of results would be. We can then run these queries, get the result set back from our search engine, see how close that matches to the perfect result set, and that really starts to give us this quality metric and understand whether search is working or not. It's all based around Trek. We have specific goal sets for intent, for spelling, for stemming. So an example of this is golf courses. So golf courses, funnily enough, are one of our, I think it's our top 30 searches that we actually get on the site. When we first built the search engine and we typed in golf courses, and we found that we're getting educational courses, universities, colleges, because we're doing a search from the city, and all of these places were very close to us. So their locality, the distance from us to them, had a huge bearing on what results were coming to the top of the page. So what we could do is we create a goal set out of this. We could identify what was the perfect set of results. And then we could start tuning, tweaking location, changing its weight, changing its importance, run the goal sets again, see if it had an impact. Did it make it better or not? And this is really that continuous cycle that we go through. Now this could take forever if you didn't have a platform to run it off. And that is where SQuAT comes in. SQuAT stands for Search Quality Analysis and Testing Platform. As you can see, it was designed by a highly experienced UX developer who spent a number of years at university working out what was the best way to develop a highly tangible user experience. I chose the colors. What SQuAT does is it exposes some of the functions in Solr that are just under the covers. So that's spelling corrections. But more importantly, it lets us run those goal sets. It lets us get a quality score out. So you'll see at the bottom, there's a run complete with a score there. That takes 30 seconds to run. We do a change, we do a deploy, we run this, and practically instantaneously, we can tell if search has been degraded or not. And if it's been degraded, then we don't deploy. It's as simple as that. And this is really how easily it shows you where your problems are. The highlighted blue rows, those are the fields that should be brought back for a particular query. The greenish color, those are the rows that shouldn't be brought back. So very quickly you can identify where there's a problem, and once you've identified what result is a problem, then you start to interrogate it. So that tree structure on the right-hand side, that's basically how Solr calculated a particular score. What was the impact of weights on content fields? What was the impact of payloads? Where did a boost work or not? And you can literally dive down into that tree structure and work out why a particular result appeared where it did. And once you understand what made a result appear where it did, you can start to tune it. So we built, again, very rudimentary, but to be honest, brilliant platform that allows us to use sliders to change the weightings on our content fields. So whether that be a title, some metadata on a particular business listing, a business description, a 100-character business description, location, each of these different content fields, we can either increase the weighting or decrease the weighting. And then we can run the tests again, see what the impact was. Now, unfortunately, this bit's in Excel, and at some point we want to build it back into the solution. But as you can see, for a particular result, across the different tests, we can find out whether a tweak made those results better or worse. And we do this multiple times, find out what the optimum setup is. Then we export that as a Solr config file, put it into Git, it goes into the next build. When we do another build out using Hudson, that Solr config gets imported in, deployed out. It's that easy. The key thing is just speed. When we first built the API, we were about 3 weeks away from launch. And we did our first set of tests, and search was pretty bad. It was, out of 100, you were about 20%. So at every 10 results, 2 were correct. We went from 2 of every 10 results to 6 of every 10 results being correct in a matter of 2 weeks by literally using this, doing some tuning, looking at why a score was calculated, a little bit more tuning, running the goal sets and seeing what the impact is. It is amazingly powerful. And we wouldn't be where we are today without Squat. All I need, there's actions or something like that, isn't there? Squat, but I don't know. Some of the hurdles along the way, because everybody wants to know where your pain points were. As I mentioned, local search content is really shallow. So we have a high degree of redundancy and homogeneity across our corpus. This causes us problems. We get around this by supplementing our listing data with historical data. So we enhance documents on ingestion to really beef them up. For example, you're searching for a dentist. You type in the word toothache. Not many dentists put the word toothache in their advert. It's not very positive. So you need to use these like synonyms and just enhance the documents. Rare terms. So Solr's ranking of rare terms, we found actually pushed some really irrelevant results up to the top of the results page. A great example is florists. So you search for florists and we're finding crematoriums who sell flowers actually coming to the top because flowers in a group in the category crematoriums is quite a rare term, therefore gets pushed up to the top of the site. So we got around this by doing content field aggregation. We actually aggregated some of these key terms or metadata with business categories together and then started to index those. And that got around the problem of these rare terms. Intent differentiation. Again, a name search, looking for a business name, and looking for a business type are two very different searches. You look at very different pieces of content. As we move forward with product search, again, different pieces of content have different values, have different weightings. You need to deal with them differently. And that's really how we've done it with intent differentiation. It's a little bit sledgehammer to crack a nut at the moment. We want to finesse it. We want to get much more like a scalpel. And we're going to be building that. I'll talk a little bit about that on the future work. But intent differentiation is really how we see ourselves beating the other local search players in the marketplace. To be honest, it's how we see ourselves beating Google in local search, because A, it's our content, but B, it's our users. So we can really drive down to specific intents. And once you know specific intents, understand the context, some of the relevant results you get back really blow your mind. The final hurdle was contextual synonyms. So synonyms, you have to use synonyms. Synonyms in a corpus is fine, but when you start to think about different words in their different contexts, synonyms actually start to have different values. So let me use the example of bow. So B-O-W. You probably can't understand my accent, but anyway, it's why I spell. Ribbon is a synonym for bow if you're thinking about bow in the realms of clothing, about clothes making. But if you're thinking about archery, so you're actually typing in bow for bow and arrow, then ribbon is not a synonym. It's actually completely irrelevant. So what we tried to do is look at contextual synonyms. So depending on the category that a business was in, we would either take the synonym and put a different weighted value onto it to either say it was more important or less important. Now again, this is a little bit of a sledgehammer type approach to fix our synonyms problem. We need to look in the future about how can we do this more automated fashion, because at the moment we manage huge lists and I've only got a team of 5 people. It's fine at the moment because I'm only looking after one API, but as soon as I start to roll this platform out for our internal clients, we really need to get into some of that automated fashions and not big long lists. So it's a solution for the moment. It's probably not the solution for the longer term. And finally, where does the future hold for us? What's out there? First is the query engine. As I said, this intent analysis. What we want to do is understand what is the intent of the user, categorize their search based on different intents, and then we want to enhance the query based on those intents. So at the moment we enhance the documents, we add in additional keywords, additional metadata to the document on ingestion. That increases the amount of data that we're ingesting. You know, we're ingesting huge amounts of data for limited value. What we want to do is actually enhance the query on the way in. So that's what the query engine is going to do. We can also get to things like business rules engines. You know, for particular times of the day, you want to push certain synonyms or use language in certain ways. The ski example, for instance. So a business engine will allow us to do that. Facets and auto-suggest. So one of the interesting things is when you're building a search API, you're building something for a third-party publisher and you don't know how they're going to use it. You don't know the user interface that they're going to build it on. So you want to make it as easy as possible for them to A, integrate into your API, but B, really have those features that allows them to build something in a very short amount of time that enhances their consumers' ability to search. So things like out of the API, having faceted navigation structures, having an auto-suggest feature within the API. So you've got a type forward. You know, every time you put in another letter, we do another search and give you back another list of auto-suggest features. Real-time tuning. At the moment, we have tuning in our test environment. We export a Solr config file and then that gets deployed. I'd like to get more into an A/B environment where we can actually do real-time tuning in our production environment. My ops people are pretty much against this at the moment because they think I'm going to break something. But we'll see, you know, I'm ever hopeful. Machine learning. Again, as I said, I've got a really small team. I want to start to use more machine learning. Click-through feedback, you know, relevancy feedback. This result gets clicked through, you know, 50% of the time. Therefore, it probably is more relevant than a result that gets clicked through at 5% of the time. How can I take that information, feed it back into the search engine, so then it's automatically creating rules and weightings to move ranks around? That's something we're looking at. Multi-term queries. You would have thought this would have been easy, but it just isn't. 2 terms we're pretty good at. As soon as you start to get to 3-term queries, relevancy starts to take a nosedive. So boat repair services, for example. The way the query handler evaluates those tokenized terms across our corpus means that actually boat sales comes to the top more, because boats is more of a common term within our advertisers who sell boats, not who repair boats. Dollhouse repairs is another funny example. I don't know why people search for dollhouse repairs, but they do a lot. How do you split those things up? You actually want dollhouse to be tokenized together and repairs as the action. But what we actually get is house repairs coming up. So again, how do you tokenize those different terms to actually do multi-term queries a lot better? Scoring thresholds. This is a really interesting one. Because we use location as part of the relevancy model, every business in Australia who matches the criteria is relevant. So if you know, Australia is a big place. If I'm in Perth versus being in Melbourne, that's about a 4-hour flight. So there's no point in really giving me, relevant results for a local florist if I'm in Melbourne for somebody who's in Perth. But because of the way that we've created this location algorithm, all of those results get brought back. So we want some way of dynamically understanding, based on the quality score of the results given back, what is an irrelevant result versus an irrelevant result. And that's going to change. It's not like the bottom 10% are always irrelevant. It's going to change on the corpus, it's going to change on the keywords. So we want to look at that and dynamically change that. And finally, content value. Both from a critical mass perspective, we're gathering content all of the time. When is enough content there to be able to search upon? Is it when a couple of business listings have got it? It's in a couple of documents? Is it got to be across 10%? Is it got to be across 20%? We don't know yet. So that's something we're really looking into. But also, more importantly, content value as part of the relevancy model. We're an intermediary. We're there to help a consumer find a business to meet their need. We can give them a list of businesses, but then it's about the consumer selecting the right business to meet their need. So the information that's published on that advertiser has different values. The more information, the more value it has, the better it can support a consumer's need. So how does that fit into the relevancy model? Certain pieces of content have more value depending on what the consumer's doing. So again, if I'm doing a search for a restaurant, a business listing with a menu probably has more value to me in making a decision. So I need to take all of those businesses who have a particular content type and then start to rank that more highly. So again, content value, how does that change based on the context? So that's all in the future. That's the next, 6 weeks, something like that. So that's it. Really, that's what we're doing with search. It's where we're taking search. It's why we've used Solr. I hope that it's given you a little bit of insight into where the local search marketplace is going and why Solr is helping us with that. If you've got any questions, please ask. If they're technical, it might be best to send them to our Twitter feed so that my techies back home can actually answer them for you. Have a look at the Developer Center, have a look at our documentation, why we do things, how we do things, sign up, build something. So, any questions? So the question was the squat tool that we've built, is it something we want to keep closed or do we want to open source it? It's funny because I did a run through of this presentation before I came out, And that was the first question somebody said that would be asked. So I went back to our lawyers and said, let's think about it. At the moment, it's no plan to open source it, but it is definitely something that we're going to think about. As I say, it's really helpful for us, and if anybody wants to talk to me afterwards about what we've done with that, please come and grab me on the shoulder. Yes, so the question is, are goal sets, data changes over time, and how representative are they? In the past, we've been quite lucky because our data hasn't been that volatile. It might change, a business might update their listing 2-3 times a year. So it hasn't been much of an issue. We're moving into a phase now where we're really increasing the volume of content that we collect and how volatile it is and how often it changes. So that's actually going to be a key problem for us. We've got about 500 goal sets at the moment. We plan to develop another 500 over the next 3 months. And these goal sets are all based off path analysis, so volumes of usage on the site. So we look at how the site's used, we take the top 10% of queries on the site, and then we start to turn that into goal sets. So at the moment, it's not a problem. It's going to start to become a problem, and we're going to have to build that again back into that goal set management to make sure they're up to date. Absolutely. Great. Well, thank you for listening, and I hope you enjoy the rest of the conference.